Dear students, Assalamu alaikum. Today we'll discuss the derivative of the function of function. आज तक तो हमने देखा है कि हम करते आए हैं कि we're asked to determine dy by dx, that is the rate of change of y with respect to x. Now, आज हम डिस्कस करेंगे the derivative of one function with respect to another function. आप देखिए किस तरह से करेंगे. If we are asked to find d f of x upon d g of x, यहाँ पे we are asked to determine the derivative of function f of x with respect to another function g of x. Instead of y, we have g of x. Sorry, instead of y, we have f of x. Instead of x, we have the function itself. So we'll take an example. Things will be clear. Example first. If ऐसे लिखेंगे, differentiate sine of x with respect to cos of x. It's interesting. We're asked to determine the rate of change of sine of x with respect to cos of x. देखिए क्या करेंगे, इसमें आप हम यूज करेंगे जो हमने प्रीवियसली डिस्कस किया था पैरामीट्रिक फॉर्म, वही हम इसमें भी यूज करेंगे. देखो आप क्या करेंगे, let u is equal sine of x. We'll take sine of x as u, and now u is the function of x, and v cos of x, v as a cos of x. Now we'll treat x as a parameter, and finally we'll get du by dv. What is that? Rate of change of u with respect to v. That is clearly derivative of sine of x with respect to cos of x. Now differentiate with respect to x on both sides. यहाँ पे भी करेंगे और यहाँ पे भी करेंगे, तो we get du by dx, that is cos of x. Is it clear? So in this case we'll get again differentiate with respect to x on both sides. Yes, on both sides. dv by dx is equal to minus sine of x. Now we'll combine the two to get the value of du by dv, that is rate of change of u with respect to v, that is rate of change of sine of x with respect to cos x. Now du by dv is equal to du by dx upon dv by dx. What is that? That is cos of x divided by minus sine of x, that is minus cot of x. Minus ऊपर हो या नीचे हो या बीच में हो, it is one and the same thing. Cos x by sin x, that is equal to cot x. We got rate of change of sin x with respect to cos x, that is minus cotangent of x. Is it clear? Okay. You can copy it. We'll take another example. आप लिखिए example second. Differentiate sine cube x with respect to cos cube x. In the similar way as we have discussed it, example first, हम क्या करेंगे, हम put करेंगे let u is equal to sine cube x. Clear? Now we'll differentiate it with respect to, now you'll treat x as a parameter. Differentiate with respect to x on both sides. We get du by dx is equal to thrice sine square x into sine का derivative, that is cos x. It is 3 जो है इसको नीचे लाना है, यहाँ पे 3 minus 1 बनेगा, that is 2 into integral, that is sine x का derivative, that is cos of x. In the similar way, we'll put, suppose v is equal to cos cube x. differentiate with respect to x on both sides. We get dv by dx. It is thrice cos square x into cos x ka derivative minus sine of x. No doubt this is multiple there. Now we'll combine the two. Du by dv now is equal to du by dx upon dv by dx. You have to divide the two. It is thrice sine square x into cos of x. इस माइनस को पहले लिखेंगे minus thrice cos square x into sine of x. Now we'll cancel this similar terms. अब देखिए 3 and 3 will go. This sine and square will go. Cos and square will go. You are left with minus sine of x divided by cos of x, that is minus tangent of x. Is it clear? That is the rate of change of sine cube of x with respect to cos cube of x, that is equal to minus tangent of x. You can note it down. We'll take another example, that is example 3rd. ऐसे लिखेंगे example 3rd. Differentiate e raised power tangent of x with respect to yes, tangent inverse x. We have to differentiate e raised power tangent of x with respect to tangent inverse x. Solution. देखिए, let y is equal to e raised power tangent of x. Now we'll differentiate it with respect to x. Again, आपको मैं रिमाइंड करूंगा कि x जो है will treat it as a parameter. यहाँ आप निकालेंगे we'll put not y, we'll put this as u, और इसको v लेंगे, इसको भी differentiate करेंगे, इसको भी differentiate करेंगे. पहले में से आप निकालेंगे du by dx, दूसरे में निकालेंगे dv by dx, फिर divide करेंगे दोनों को. हाँ, differentiate with respect to x on both sides. You know, this is du by dx, this is e raised power tangent of x. हाँ, यहाँ पे बताइए कि पावर का डेरिवेटिव जो है ना मल्टीप्लाई करना है, टेंजेंट x का डेरिवेटिव मल्टीप्लाई करना है, दैट इज यू आर राइट, दिस इज sec square x. हाँ, सपोज हाँ दिस फंक्शन टेंजेंट इनवर्स x जो है ना, ये लेंगे v. सेम लाइन ऑफ एक्शन इज देयर, सेम पैटर्न इज देयर. We'll differentiate with respect to x on both sides. We get dv by dx. What is tangent inverse x का differential coefficient? We have discussed this last time. Inverse trigonometric functions. Tangent inverse x का derivative. You are right. It is 1 upon 1 plus x square. Now we'll combine the two. Du by dv is equal to du by dx upon dv by dx. What is du by dx? It is e raised power tangent x into sec square x divided by 1 upon 1 plus x square. जब इसको ऊपर चढ़ाएंगे ये आएगा इस तरह से, e raised power tangent of x into sec square x, then we have into 1 plus x square. You can copy it. We'll discuss another example. Differentiate, this is example 4. Differentiate secant of x with respect to cosecant of x. Okay, क्या करेंगे? As usual, let u is equal to secant of x. We'll differentiate it with respect to x on both sides. Differentiate with respect to x on both sides. We get du by dx. Secant x का derivative, sec x into tangent of x. You have to remember these results, that is the derivatives of circular functions, by heart. Suppose v is equal to cosecant of x. Now इसको भी differentiate करेंगे. Differentiate with respect to x on both sides. We get dv by dx. cosec x का डेरिवेटिव किसके बराबर होता है? माइनस cosec x into cot of x. माइनस cosec x into cot of x. We'll combine the two. Now dy by dx is equal to dy by we require du by dv. Here it is du by dx upon dv by dx. Du by dx, what is that? That is secant of x into tangent of x upon minus cosec x into cot of x. You can keep it right as it is, no problem. This is the required differential coefficient of secant of x with respect to cosecant of x. You can copy it. We'll take another example. Example 5th. Example 5th लिखिए. Example 5th. Differentiate log of x with respect to tangent inverse x. Very easy. On the similar way as we have discussed it previously. Suppose क्या करेंगे solution के लिए? Suppose u is equal to log of x. As we know that the derivative of log of x is that's 1 upon x. हम लिखेंगे differentiate with respect to x on both sides. We can write du by dx is equal to simple. It is 1 upon x. As we have discussed this by first principle also, derivative of log of x is 1 upon x with respect to x. Let v is equal to tangent inverse x. Differentiate with respect to x on both sides. We get dv by dx is equal to, ये भी पता है आपको कि tangent inverse x का डेरिवेटिव किसके बराबर होता है? 1 upon 1 plus x square. Now we'll combine the two. We'll get du by dv. कैसे? du by dx whole divided by dv by dx. Now du, as usual, du by dv is equal to du by dx upon dv by dx. आप देखिए du by dx that's 1 upon x divided by 1 upon 1 plus x square. इसको ऊपर चढ़ा के रिजल्ट आएगा this is the derivative of log of x with respect to tangent inverse x. What is that result? That's 1 plus x square divided by x. That is the rate of change of log of x with respect to tangent inverse x. आप कॉपी कीजिए. I'll give some assignment questions. You can try those questions at your place at home. Assignment. Question number first. Differentiate sec square x with respect to tangent square x. Number first. Number second. Differentiate sin square x with respect to sin x square. This also interesting. यहाँ पे आप देखिए square is for the whole sin x. यहाँ पे square जो है it is just for x angle के लिए square. Third, differentiate tangent inverse x with respect to cos of x. Fourth, differentiate e raised power x with respect to cos inverse x. One more, differentiate sin cube t with respect to cos cube t. यहाँ पे आप पैरामीटर t लेंगे, you will put this as u and this as v. Finally you will get du by dv. Okay, this is sufficient for today. Thank you.